Good morning, everyone, and welcome to the latest Motec webinar. This one is to do with ref sync troubleshooting. So basically what I'll be going through today is a bit of an extension of my last two webinars relating to ref and sync, so the crank and the cam triggers, and how to make the ECU work with them, how to set them up, etc. So by troubleshooting, we're basically going to go through some common problems and some specific remedies, if you were, or how to go about diagnosing exactly what the problem is. The topics for today are going to include syncing. Now, it's a word that we here at Motec use a lot. It's a bit of Motec jargon, and I'll explain why that is so important. We're going to go through things like your RPM checks, your ref sync captures, the difference between errors and warnings in the ECU software, and then we're sort of going to review a couple of things that have probably been over a few times before with the ref sync edge polarity, trigger voltages, cranking speed, and our tooth ratio setting. And at the end, I'll go through some basic common mistakes that we sort of see here all the time. Just one thing for everyone to remember is these subjects are based on more or less the phone calls we get here in support or the emails we would get. So just remember these as a bit of a checklist of if you are going to ring Motec or send an email or put posting on the forum, these are the kind of questions that you'll be hit with almost straight away. So let's continue. Syncing. It's a term we use, it's probably Motec jargon. It basically means that the ECU has read the ref and sync trigger patterns coming in on the ref and sync inputs, and it has understood them. So if you go to the diagnostic screen in the M800 software by pressing F3, you can even press V for view and then scroll along. There's also a status tab there as well. That will have the ref sync synced or ref sync not synced status on that same page. So basically we're saying if the engine is off, not turning, obviously your status or your error is going to be that the ECU thinks that the engine's not synchronized. Basically the engine's not turning, so how can it read anything? As soon as the engine starts turning, the ECU has to read the ref and sync trigger patterns. It has to decide if it can understand them or not. If it does understand them, then your status or your error will turn to ref sync synchronized, and it'll have a little OK next to it. That means the ECU completely accepts those two signals coming in. It is extremely important for one very simple reason. The ECU must understand where the engine is in its cycle to be able to fire, fuel, spark. Fairly logical. The ref and sync sensors are quite simply the ECU's only references to where the engine mechanically is in its cycle. No syncing simply means the ECU does not understand the ref and sync pattern. The engine's turning, the ECU will say, okay, well, I can see that the engine's turning because I'm getting something, but it's looking for a specific pattern, which I'll explain a bit more later. If it doesn't see that pattern, it will simply say, I don't understand. And if it doesn't understand, it will not even attempt to fire injectors and ignition. Why? Simply because it doesn't know where to fire them, because it doesn't understand the information you're giving it. This is normal. So pretty much if you rang or sent an email or posted on the forum and said my engine won't start, I'm getting no injectors or ignition, the absolute first question any of us are going to ask is, if you go to the errors or the status page, does the ECU become synced? That's the first port of call. Now, just one thing to make very clear is this syncing status or error, as you will, it's completely separate of the crank index position setting. I suggest that you go back and look at my other ref and sync webinars so I don't have to completely re-explain what crip is, but it is independent of that. You can have the crip wrong, but the ref and sync still correct. They're kind of independent. Just one important note to remember. If you're talking to one of us and basically the answer to our question is no, it's not syncing, the first check you would go to is the RPM. So when you crank this engine and looking at the ECU screen, do I get one, a believable, and two, a consistent RPM? So in your ref and sync setup, basically the ref's signal's first job is to measure RPM. Is the crank turning? What speed is it cranking at? So, as an example, like a Chev V8 or something might crank at 260. You've got a pretty good idea. Some of the smaller bike and jet ski engines might crank at a higher than that or lower than that. You just need to have an idea of what should this engine be cranking at. And then you can see in the bottom left-hand side with the circle, if you press S, that will give you the sensors view screen. Front and center, top right, you've got the RPM. So you can read it there. I would prefer, if you have a look to the right, is that you actually put a chart recorder and maybe a dial gauge there. They're a bit easier to sort of read. The chart recorder has a bit of history. So we can see in that example, yeah, the RPM's moving around a little bit, but that's to be expected as the engine cranks, comes up onto compression, slows down, speeds up, that kind of thing. So I would look at that RPM trace and say, well, that looks all right. One suggestion that I would make is that the update rate of the laptop screen and its resolution probably isn't as good as high rate data logging. So most of the time, if I was trying to solve this via email or the phone, I would request some data logging, and I would have the customer log the RPM at the maximum rate, which was 200 hertz, and you'll actually see a little bit more information in the RPM trace in the logging compared to what you see on the laptop screen. Just a couple of examples here. Well, obviously that top RPM trace, I would surely hope that no one's engine cranks like that. Now, if you can sit there and think, well, I can sort of hear the engine seems to be cranking fairly consistently and what I'd expect, I'm pretty sure the RPM isn't doing that. What you would sort of have an idea about is, well, what measures RPM? The ref measures RPM. Maybe I've got some problems with my ref input. So the ECU is reading, let's say, invalid information coming in compared to what the engine is physically actually doing. And below that, the low RPM, well, that's a fairly sort of common sight for us when people have made a mistake with either their wiring or their setup, where quite simply the engine should be cranking at, say, 200, 250 RPM, but it says that it's cranking at 30 RPM. Again, means you've got something wrong in your setup and you need to resolve that. As mentioned pretty much ad nauseum in all our seminars and webinars on RefSync, we have this RefSync capture. So under utilities, you go to the RefSync capture, you wind the engine over and hit capture, and you will get a oscilloscope view of the voltage waveforms coming in on the ref and sync input. So on this one is a blue trace for the ref and an orange trace for sync. It might be disjointed on some of your screens, but that's the sort of idea that you'll get. So from this information, one, we can tell what the pattern is, how many teeth on the crank, what type of sensors they are, etc., to back us up to make sure that we have entered the information correctly. The ref sync mode number that you enter is, we're talking about this, the ECU recognizing the pattern of teeth. The ref sync mode that you set in the software is more or less a reference number to a specific pattern. Does it have 12 teeth on the crank, or does it have 36 teeth on the crank with 2 missing? The ref sync mode number would be different for those two setups. Is the setting for the number of crank reference teeth correct? So we have ref sync mode. What type of pattern is it? We have the crank reference teeth. Now the crank reference teeth setting is how many teeth do I have per 1 crank revolution. Now just as a quick reminder, based on our previous ref sync webinars, a missing tooth mode, let's say I have 36 minus 2 teeth on the crank reference teeth is 36. It's the number of evenly spaced teeth that would be there if I hadn't cut a couple off. So 36 minus 2, it's 36 teeth, not 30. Next, does the ECU, is it actually seeing both the ref and sync signals? Now, that ref sync mode number is a reference to a pattern, and that pattern is the ref and the sync patterns together. It's not one or the other, it's the two combined. Now, if you have a bit of a worry that you haven't quite got your ref sync mode set up correct, or even the number of crank reference teeth, simply save that ref sync capture and email it or put it up on the web forum, and then we can confirm that you've actually got the right numbers. Next, I sort of want to go through ref and sync errors and also things. We need to divide the two up. They both appear on the same page, but there is a complete difference between errors and warnings. So I'll start with the errors. The errors for ref and sync are basically pattern recognition errors. So you've told it to expect 12 teeth on the crank and 1 tooth on the cam. Now, there's a specific ref sync number for that. Now, if the pattern does not match that, then the ECU will simply say, hey, look, you've told me to expect a certain pattern. When you wind the engine over, comparing the ref and sync to each other and then to that mode number, something's not right. I haven't got the right number of ref teeth. I haven't got the right number of sync teeth. The ECU compares the two signals. If you have any of these errors, the engine will not run. Okay, so this will stop the engine running. These are the errors. So just I've got a list below: the error ref signal, error no ref, error sync, error no sync. Now, the error ref signal and error sync signal, unfortunately, they're a bit of a chicken or the egg. See, the ECU is comparing ref to sync, so it doesn't really know which one is wrong. It just knows that between the two, there is a problem with the pattern. The error no ref and the error no sync, well, they are reasonably obvious that one or the other is basically missing. So I haven't got a sync signal or I haven't got a ref signal. So like I said, the ref and sync mode number is the comparison of the two. If you're missing one, well, obviously that mode number is not going to work and you need to sort that out. So again, back to your ref sync capture. Is the, I don't know, the sync signal unplugged? Have I simply put in the wrong ref sync mode? Something like that. Warnings. Now, warnings are for signals that are not quite perfect, and the next couple of slides I'll sort of give you some examples. These by themselves will not stop the engine running, okay? So that list of 4 there, there's the ref sync, noise AR, noise TR, runt, and the low level. They're basically saying, hey, look, something's not perfect, but if you only get one of those warnings, it's not a pattern recognition error. So it will not stop the engine running. If you have those, the combination of the errors, then the engine will stop running. But it's the errors that are stopping the engine running. And as I sort of mentioned before, these warnings appear on the errors page. So, some people sort of worry and ring up and say they've got like a sync runt error and the engine won't start. Well, my suggestion would be that the sync runt error is not stopping the engine running because you haven't got the ref or sync error or no ref or no sync error. Those are the ones which will actually stop the engine running. A quick explanation of your noise AR and TR warnings. I'll just run through this fairly quickly. Basically, you set up a filter table, as in my previous webinars. Now what we're saying is if you have a noise spike in the top right hand corner there from, say, the ignition, they're very short duration but quite high voltage. Basically the noise AR or TR error says, look, this spike is longer than half of filter, but it hasn't exceeded the filter time. So if you say 80 microseconds is the filter and you get a spike of 41 microseconds, you get the AR and the TR warning. Now it just basically says, hey, look, there is something that I can see. I have filtered it out, but I'm just going to warn you that it's there. Something for you to keep an eye on in the future. For ref and sync runt errors, basically what we're saying is when we set our mag voltage table, so we've set that at our 30% of the halfway voltage. Again, probably need to go back to my earlier webinars. What we're saying is we've got a spike. It might be ignition. It might be a casting mark on the crank trigger. That voltage has gotten close to our set mag level, but it hasn't exceeded it. So the ECU is warning you that there is something in the background. It has successfully filtered it out, so it's not going to stop the engine running. If that voltage spike exceeded that voltage level and it did get counted as a problem, then you'd go back to your main errors where they would basically say, hey, look, I've had a pattern recognition problem. I've picked up this extra tooth. The pattern doesn't match my ref or sync mode number. Then the engine will stop running. So again, the warnings by themselves do not stop the engine running. Again, a bit of a practical sort of explanation of what you're probably likely to see when you're trying to start an engine. The ECU will calculate these errors and warnings as soon as the crank starts turning, as soon as it sees RPM. So if you were looking at the diagnostic errors page as you started the engine, in the first quarter, half a turn of the crank, you are likely to get some errors. Simply the ECU hasn't seen the full pattern yet, so it's calculating errors on something it hasn't seen. The idea is, as you're winding it over, hit enter. So as soon as you hit enter, it resets the errors. So classically, you would hope that all of those errors go away once the engine was cranking and never came back. If you have an error that keeps continually reappearing as you're cranking and as you're hitting enter, that's the one you have a problem with. So you need to work down that track of what is going wrong. So just these now are going to recap on a few things just to let you know, that these things are quite important. One thing we see quite often is people getting the edge wrong. Now, with some of the more complex ref and sync modes, like for some of the cars with variable cams, etc., you will not get away with having the rising edge or the falling edge of a magnetic sensor configured incorrectly. Some of the earlier modes, it was still going to cause you a problem, but you might not notice while starting the engine. But be very sure that you have the edge polarity correct on ref and sync magnetic levels. So you can see here, the top ones are rising, and the bottom one's a falling edge. So must be right anyway, but it's something to check if you're having ref and sync issues. Trigger voltages. Again, this will only ever appear if you have a piggyback system. So you've got the Motec sharing ref and sync information from a factory ECU. So basically, some of the factory ECUs will move the baseline, or instead of triggering the system at 0 volts, they might trigger it, say, 1 volt. So sometimes you've got to be a bit careful with piggyback systems, because if there is a reasonable amount of trigger voltage offset, the ECU will not recognize it if you haven't accounted for that offset. So there's no need to worry about any of that if it's purely a Motec standalone installation. So this is, just be aware of this if you are piggybacking. Okay, this cranking speed and tooth ratio is becoming more and more of a thing to be aware of. Modern engines will generally these days have a set of missing teeth rather than evenly spaced crank triggers. So I'll give this example down the bottom here is a 4-cylinder motorbike engine. So you can see that as the engine cranks, it comes up onto compression, crank slows down, so therefore the magnetic output gets lower. Now, in amongst that somewhere, I've circled them in red, the ECU has to decide, okay, well, where are the missing teeth? So this is a 36-2 crank trigger. So it's basically saying, well, I need to be able to see these missing teeth. So as the crank is speeding up and slowing down, the ECU is also trying to look for a gap where 2 teeth have been cut off. Now, that gap, as the crank slows down, that gap can actually look, well, to the ECU as though, well, the crank just slowed down even faster. So we have to be a little bit careful setting up our tooth ratio parameter. Basically decides how does the ECU look at missing teeth. One good way to just sort of check if you have a cranking consistency problem, if you are pretty sure that everything else in your setup for ref and sync is correct, but the ECU still won't sync as you crank the engine, simply pull the spark plugs out. So this will remove our compression strokes more or less, and the cranking should become more consistent. If suddenly, without the plugs, the engine syncs up, or the ECU syncs up no problem, then you have a cranking consistency problem, and you need to change the tooth ratio setting in the ECU. Just another way of looking at this cranking speed inconsistency and tooth ratio setting problems. If we look down, that graph I've got down the bottom is now RPM. So when I suspect that a customer is having this problem, I will get them to log the RPM signal itself at 200 Hertz, and then I will look at that in our i2 software. Now, as the crank speeds up and slows down, obviously I'm going to get more or less an oscillation in the actual RPM. Now, one very clearly seen sort of problem with the tooth ratio is we can see that the ECU, as the crank slows down, has misinterpreted those missing teeth as an actual drop in the RPM, and you'll see this in i2. So that to me instantly says, hey, I've got the tooth ratio wrong. Now, as a practical bit of advice, this is a problem with the ref. But how it's calculated in the ECU will usually show up as a sync signal error. Again, this chicken or the egg thing, but just from practical sort of experience, that's what you will see. The way to fix this is simply go up in your tooth ratio in steps of 5. So if you're at 40, go to 45. Remember to reset the ECU, press R and then enter, and then try cranking again. If that doesn't work, maybe go up to 50, 55, something like that. At times we've had to go right up past 70% tooth ratio. You might want to start looking at your actual cranking system at that point, because once you're at the track, as my last point shows, if the battery voltage goes down, cranking consistency becomes worse. You want to make sure you're not going to get stuck in the dummy grid somewhere just because your battery's a little bit low and you haven't tested it. Okay, we're on to some common mistakes here, so I'm just going to run through. Obviously, I haven't got time to go through everything, but hopefully between my 3 Ref and Sync webinars, you'll have a pretty good idea of what you need to do. Here's an example of getting the Ref Sync mode number wrong. I had a customer sort of with this problem the other day, really. Remember that the Ref Sync mode is a combination of the Ref pattern and the Sync pattern. Basically, the top one is what we affectionately call our BMW mode 17. It has 60-2 teeth on the crank in blue, and the sync signal is actually 4 teeth, too short, too long. That has a specific ref sync mode number, which is number 17. The bottom one is the same crank pattern, but a different cam pattern. Now I had the customer basically had the top pattern. He had the BMW mode 17, but he'd only been looking at the crank trigger pattern, so he set it up accordingly. So, basically as soon as I got his ref sync capture, I said, well, your mistake is you've got the crank trigger right, you know what that is, but you haven't matched it to a ref sync mode that includes the right sync pattern. So ref sync capture, wind the engine over, save it, send it to us, and we will show you where you've gone wrong. That ref sync mode number is highly important. If the ECU doesn't understand the pattern coming in, it simply will not try to fire the engine. So make sure your ref sync mode matches. Another common mistake, this is a bit of a practicality thing. What I find quite a few people do is they'll actually look at the physical crank teeth and count them. Now, on the left there, we have a fairly typical Toyota crank trigger, and on the right, we have one that we actually made up here. Now, notice that on the right, it kind of looks like we've actually cut 2 teeth off that originally were there. And on the left, it looks like they've cast in one big long tooth. Now, the one on the left, people will sort of count that as 36 minus 3. I won't go into the counting yet, and the other one on the right, they'll count as 36 minus 2. They're both actually 36 minus 2. One thing that you must remember is these trigger discs, and they're most commonly matched with a magnetic sensor these days. The magnetic signal output may not quite look logical compared to the physical teeth. So what I would suggest is if you have either of these 2 type of crank triggers, the ref sync capture is more friendly to you than actually counting the physical number of teeth, because I've had people make many a mistake by misinterpreting it and sending us sort of information that, well, it wasn't quite right. So the ref sync capture, if you've got a question, the ref sync capture is what the ECU sees. That's how you should be setting it up. Common mistake, setting your mag level table too high. So let's say that signal there is 6 volts from complete negative to complete positive. So the half wave voltage is 3 volts. So just the positive part above 0 volts. So if it's 3 volts, magnetic level table should be 25 to 30% of that, so 1 volt. If you set that at, say, 3.2 volts, well, all the ECU is going to do is completely filter out that entire signal. So your filter level is 25 to 30% of the positive voltage of that signal. You put it above there, well, quite simply, the ECU is going to filter out the entire, let's say, ref signal. If there's no ref signal as far as the ECU can see, it's going to have a no ref signal error. Engine won't start. So just make sure that you measure, again, ref sync capture, what is the halfway voltage, so we're measuring anything above 0 volt line, 25 to 30% of that, that's what you need to set. Another common one is setting the filter time too long. If the filter time's too long, the ECU filters out my ref pulse, sync pulse altogether. Again, ECU doesn't have that information. If it can't see that pattern, it's going to try to match it to a ref sync mode. It simply won't work. I find a lot of problems with people setting the filter time too long at high RPM, and a fairly good one is the engine will rev, we'll get to say 6,000 RPM, the filter time's too long, and quite simply the engine shuts down at 6,000 revs. So make sure that that filter time needs to get smaller with RPM. As the RPM gets faster, those signals get shorter and shorter and shorter. So your filter time needs to get shorter and shorter and shorter to match. So over filtering, fairly common mistake. The other one, and I would probably see this, this is actually one of my favorite questions at seminars when I start talking about magnetic signals, is how do you determine whether it's a rising or a falling edge for a missing tooth? So the top and bottom are basically the same crank trigger with two missing teeth. Now the top one is a falling edge. You can quite clearly see where the missing teeth are because there's a bit of a stretch in the signal. Now, a lot of people, I think they're assuming that you need to specify the edge where the missing teeth are, but the underlying fact is that the ECU is looking for the most straight crossing of the 0 volts, and on that top one, it's the falling edge. So it must be falling edge for that top one. And down the bottom, I've simply reversed it just to give you an idea. It needs to be a rising edge, the straightest crossing or the most perpendicular crossing of the signal through 0 volts. That's what you must set. Now, I will tell you that if you get the edge setting wrong on one of these missing teeth, it will not sync up. Okay, so that will stop it, and it will, again, as I said previously, most likely come up with a sync error, even though it's caused by the ref. So again, ref sync capture, have I got my edge right? Now, here's one that we don't see quite as often anymore because these kind of setups are fairly uncommon. But if we have a Hall sensor where the signal is a square wave, either the rising or the falling edge is valid as far as signals go. But remember, this is the combination between the ref and sync. If we sort of imagine that the falling edges of both that ref and the sync are perfectly aligned, the ECU is never going to be able to really tell which one came first, especially when you think that maybe the crank and the cam trigger bounce around between each other. Hey, you know, we've got a timing belt or a timing chain between the two, so they're never going to be perfectly mechanically locked. So as you can see on my little table there, falling edge for both of them, can't use it. It won't work. Any other combination, we just want to keep the two active edges as far away as possible from each other. If you set that up with the falling edge for both of them, then yes, quite simply what is probably going to happen is as you're winding it over, you're going to get a couple of pops out of the engine, it's going to sync up, then it's going to go into error, then it's going to sync up, then it's going into error, and the upshot is it makes a lot of noise but doesn't actually go anywhere. First thing to look at, do I have Hall sensors? Do I have the ref and sync edge lining up? This is for even tooth modes only. If you've got a missing tooth mode, then I would suggest that the sync is generally a long way away from the missing teeth, so this won't be your problem. This is an even tooth mode. And just sort of finally a bit of a recap, and this is more or less a checklist of what you really should be doing when you're trying to diagnose these problems. So first, have I got my ref sync mode set correctly? ref sync capture. Make sure the crank reference teeth setting is correct. So how many teeth should this ECU see for one revolution of the crank? So these are probably the two most important things. It's setting up, what should the ECU see in one complete cycle of this engine? How many ref teeth? How many sync teeth? What kind of pattern are they? Most important. Next, sensor type. Have I accidentally set the ECU to look for a Hall sensor when realistically it's a magnetic sensor? Again, ref sync mode is going to tell you all of this. Our sensor edge. Okay, I've got a magnetic sensor on the crank. Have I got the edge around the wrong way? Again, ref sync capture. And for the rest of them, ref sync capture again. Do I have my filters set correctly? Filters work for Hall and magnetic. And the voltage levels. Have I got my voltage levels too high? They only work for magnetic. Again, previous webinars, Halls have fixed levels. And then if you have a missing tooth mode or even an additional tooth mode where I have like 12 plus 1 like the new Hondas, do I have a tooth ratio problem? Is the ECU picking up that extra missing tooth set as an RPM calculation? It shouldn't. So if I can see that in my logged RPM, then I've got a tooth ratio problem. Okay, thank you all for attending. I hope that has cleared some stuff up. It's kind of a broad subject, as we keep mentioning, but as long as I find that when trying to sort out a problem, as long as you have a clear sort of step-by-step way of going through it logically, it helps you diagnose the problem, and it also helps us with helping you. So for more information, you should join our Motec forum. Like I said, we're not here 24 hours, but there's always someone around the world on the forum. And if you want to go back and view this webinar again, or in fact all the previous ones we've done, especially the two ref sync ones that I've done previously to this, you can simply go to motec.com.au and find our webinars page for more or less a history of what we've done in the past. So again, thank you all for coming, and I hope this has helped. See you later.